Oh, hello. I didn't notice you there. It's a pleasure to visit with you virtually. I'm David Armstrong, a professor of surgery and director of the Southwestern Academic Limb Salvage Alliance, or SALSA, here at the Keck School of Medicine of the University of Southern California. Fight on. Every 20 seconds, someone around the world loses their leg because of diabetes. Every 20 seconds, that is a tragedy. This problem, the lower extremity in diabetes, is now more expensive than the 5 most expensive cancers in the United States, and this is also true in Canada and in the EU. So this is one of the biggest problems that very few people are talking about. So with all of that bad, there's a lot of good. I was recruited here and to develop SALSA with the express intention and goal of eliminating what we call preventable amputations over the next generation. And I believe very strongly that we can do it. I think all the trend lines are in that direction, marrying team and technology with a little tenacity, if you will. To that end, that's why I could not be more excited about the team we're developing and the technology that we're working on. One of them is a super cool, intelligent Insole. This is the culmination of a lot of work that's happened at our group and others around the world. We can measure a great number of things, not only pressure and skin temperature, which we've been working on for the last 25 years, but also really subtle changes in activity that could presage diabetic foot ulcer, which is what happens before someone gets an infection, and gangrene, which is what happens before an amputation. So we can get out in front of this problem. But this has even more potential, because looking at things like gait variability and modifications in how we move through the world can predict a lot of other things. We and others have a lot of data on looking at fall prevention and a lot of other things to try to rehabilitate people. We believe this is a platform technology in the truest sense. We're walking on a platform that could really make a difference. So listen, here's to helping our patients move through the world a little better every day, and here's to preventing what are really preventable problems and keeping a few more legs on a few more bodies, because I think that's what we all deserve, no matter what our health, no matter what our age, whether we have diabetes or not. And thank you very much from the bottom of my heart.
I'm Charles Liu, PhD, MD. I'm a bioengineer who became a neurosurgeon. I direct the USC Neurorestoration Center, which exists to engineer creative solutions to restore function after neurological disability. Diabetes has profound neurological consequences that need to be addressed. This technology, BioSole, is central to this effort by creating a solution to the loss of sensation and the consequences of that.
Good afternoon. I'm Eric Matella, the Chief Technology Officer at Autonomous ID, makers of BioSole. In this segment, we're going to discuss the manufacturing process used to build the BioSole using solid freeform fabrication, and we'll show a short film snippet of the manufacturing process. Secondly, we'll describe the structure of the BioSole, the 8-layered approach that is used to form a direct print to electronics using the solid freeform fabrication technology. Third, we'll discuss the usage of the BioSole in the diabetic research program that Autonomous ID has been participating in, involving relationships with several organizations, including the University of Southern California and University of New Brunswick. This graphic illustrates the 8 principal layers in the BioSole sensor array. Layer 1, found on the right, is the base layer. Layer 2 is the bottom void. Layer 3 is the bottom connectors that fit into the bottom void. Layer 4 is the sensor void. Layer 5 is a sensor array that fits into the Layer 4 sensor void. Layer 6 is the top void. Layer 7 are the top connectors that fit into the Layer 6 top void. And finally, Layer 8 is the waterproof cover that keeps the entire system secure. The data from BioSole is transmitted into the Autonomous ID through the Autonomous ID framework into a scalable, distributed, secure infrastructure. In order to meet the scalability and security requirements required to support hundreds of thousands to millions of users, in order to support or meet the requirements of HIPAA security and HIPAA privacy. And in order to meet the requirements of the NIST risk management framework, a very unique architecture was employed. In addition to the distribution architecture, which you can visually see, within each node, you find that there's 5 layers, beginning with the network address translation, or NAT layer, the demilitarized zone, or DMZ layer, the web layer, application layer, and database layer. In addition, the privacy is critical in order to meet the requirements not only of HIPAA, but in order to support doing good business with the BioSole customers. This is achieved through anonymity of the data source and through the application of a core technology that we call autonomous ID.